Hello and welcome to Unit 9, where we're going to look at one of the IPOP applications on high-throughput computing with Grid Appliance and HT Condor. So in this application of IPOP, it's one of the motivating use cases in the design of the system was to create virtual clusters that support high-throughput computing. And the goal is to be able to deploy containers for the execution of high-throughput computing tasks. So many tasks that run on many computers, for example, concurrent simulations of different design points of a particular system that you're simulating. So the idea is to be able to deploy these containers as virtual machines on cloud resources or desktops or servers, and be able to put them together into a virtual cluster that can run traditional and unmodified schedulers. And one particular example here is HT Condor, which is an open source system that's been around for more than 20 years, and it's very robust and very widely used, and also support unmodified applications. And the role here of virtual machines and IPOP is to provide an environment that supports the setup that HT Condor expects, which is a private cluster. So we have a self-configuring virtual private network of virtual machines. So stepping back a little bit, let's discuss what is an appliance and what is a virtual appliance in the context of this work. So physical appliances are instruments that are designed for a particular user function, like a dishwasher or a blender. In the context of computer systems, an appliance can be a hardware or software appliance. A hardware appliance could be a TiVo-like system where you have a TV receiver, a computer, hard disk, an operating system, and a user interface, and you put all of this together in a box that does recording of TV programs. Or it could be also, for example, a wireless router, which is a small computer with network interfaces and an operating system, and a user interface with a particular function of providing wireless routing for a home network. So what is a virtual appliance? It's an appliance that's packaged, a software appliance packaged as the virtual machine. So it packages in the virtual machine all the software and the configuration that's needed for a particular purpose. And you put that all together into a software image that has the operating system, libraries, applications, configuration, etc. And this image can be distributed and deployed on resources. So the virtual appliance itself has no hardware. It's software and configuration. You put it in a file, which is typically a large file with often hundreds of megabytes or even gigabytes in size, and you copy that on the resources that are instantiating them. They instantiate these virtual machines so they can run and perform their task. For example, a typical appliance would be a LAMP, Linux, Apache, MySQL, and PHP, so basically a stack that allows you to run web servers. So one can distribute a virtual machine with this image and deploy, after copying to resources, instantiating a web server. And repeating this process, you have another web server on another machine. So this makes convenient deployment and dissemination of software through the use of virtualization. And the virtualization layer is responsible for, through virtual machine monitors, for supporting the execution of these virtual machines on different resources. Now, web servers can run, in the previous example, you can have multiple independent web servers running their own, serving their own web pages, but what if you need to run a clustered application, for example, high-throughput computing, Condor, MPI, Hadoop, etc. Well, you can follow the same approach. You distribute a virtual machine image, you instantiate on multiple nodes, and you have a distributed system. But then you have to worry about how do you connect these resources together. And that's the role of the virtual network, and IPOP being one example of a virtual network that supports that kind of connectivity. So in the Grid appliance, we put together HT Condor and the IPOP virtual network so that you can copy this image, this virtual appliance image, on multiple machines, turn them on, and they'll self-organize into a virtual private network connecting these workers together. So the additional configuration that comes in is the group VPN credentials, as discussed in the previous unit, the security credentials that are coming from the group VPN website after a user joins a group, and that establishes the namespace. These machines are connected together and allows these machines to obtain IP addresses using the HCP within that namespace. And then they locate the scheduler for HT Condor and register themselves as the scheduler, and then they're ready to run and execute tasks. So the virtual appliance encapsulates the software environment, and this is distributed in a virtual disk file and the configuration of the hardware associated with it. And the cluster environment allows us to have a homogeneous setup. At each node that is deployed, you copy the same image and you deploy the same image. So when you connect them together, you form a cluster that has homogeneous software configuration. Even though the resources, the physical resources, the computers and the network connecting these computers could have heterogeneous configuration, what HT Condor sees inside the virtual cluster is completely homogeneous. It's a virtual private network of virtual machines that have the same software. And because of the properties of IPOP, that the virtual network can configure resources across domains, crossing nets, etc., it's possible to deploy this appliance across multiple domains, across multiple environments. For example, for collaborative research across multiple institutions. Internally, the Grid appliance has Linux as the host operating system. You can have a Grid cloud stack. Condor is the baseline stack, and you can add Hadoop and MPI on top of it. And there's glue logic, there's software for zero configuration. Aside from the DHCP address setup, it uses the distributed hash table to also help determine the configuration of where is the Condor scheduler, for example. And then there are additional scripts to interact with the virtual machine monitor and the cloud provider to configure things properly.